Welcome to my new video tool, which allows me to have my beautiful face in the bottom corner. So it's not a crazy, disembodied mathematician talking to you as you look at a PowerPoint, but more importantly, it's got an annotation tool like that. Here we are looking at surds. That's chapter 13, section 3, last section of this chapter. And a surd, as I said at the start, is a mathematical expression that's got square root signs in it. This is 3 root 72 plus 5 root 72. That's how we read those. Now, mathematicians, as you know, like to have things as simple as possible and as beautiful as possible. So we'd want the smallest number as we could inside the square root sign. We'd like to have fewer terms. We'd also like to ensure that there's never a square root sign in the denominator. It's the bottom of a fraction, or the bottom of a division sum. Getting a square root sign out of the denominator we called rationalising, because linked to the fact that some square roots are irrational. That means their decimal goes on forever. They cannot be written as a fraction. We looked at that in chapter 7, writing long decimals as fractions, and you might want to do a revision that at some point if you run out of things to do on this. Anyway, a really famous irrational number is root 2, which 1.4142 goes on forever. You can look it up on the internet and see some wonderful history about it at the top of page 264 and Pythagoras' hatred of those irrational numbers. I'm going to now take you on to the important bits and talk to you about the 4 rules that you need to know for simplifying these surds. So the first one is like the expression we saw on the first page. 4 root 2 add 3 root 2. You might sort of work out in your head that actually that can be written as 7 root 2, because I've got 4 of them there and 3 of them there. The important thing to notice is that they have to be the same square root. So if it was root 3 and root 2, then I wouldn't be able to add them up. I can only add them up because I've got the same square root. It's a bit like 4x and 3x can be added up, but I can't add up 4x and 3y. So that's a simple one to remember, I hope. Number 1, done. So number 2, this time we've got a multiplication sign. Hope you're enjoying the annotation. And this time I have got different numbers in here. But if there's a multiplication sign, I can combine them. A bit like 4x times 3y, I can write that as 12xy. Well, here, 4 and 3, again, 4 times 3 gives me 12. And inside the square root, I can put those numbers together. So inside the square root, I can have 5 and 2. 5 times 2 gives me root 10. Okay, now where we're going to need to know our square numbers. Okay, these ones here, vital you know these. 9 would also be a good one to know. 9 nines being 81. Anyway, what I'm going to do here to try and make that number smaller, because that's what one of the aims to make things more mathematically beautiful, I'm going to see if there is a square number which is a factor of 72. Well, you can see there I've written 36. 36 is a square number. 6 times 6 is 36. So I can write in here the factor pair 2 times 36, because that makes 72. Because 36 is a square number, I can take it outside of the square root and make it 6. The square root of 36, and I take it outside there, becomes 6. So now I can combine 3 and 6 to make 18, and root 2 is left there. Moving on to the last one, the 4th rule here. This is where we're going to be rationalising. So I want to get that square root off the bottom. The question you'd be given is this: 4 root 10 over 3 root 5. And you'd be expected to make that look more mathematically beautiful. So root 5 times by root 5 goes to 5, because the opposite of squaring is square rooting. Square root of 5 times the square root of 5 takes me back to 5. So when I multiply these together, 3 stays there. Root 5 times root 5 gives me 5. So in total on the bottom, I've got 15. Bottom is essentially done for now. If I've done the bottom by root 5, I'm going to also multiply the top by root 5. So again, similar to this rule up here, that 5 can go in there with that 10. So I've still got the 4, but inside here I've now got 5 times 10 because I had that root 5 from there. In total, that gives me root 50. I'm now going to be using this idea. Is there a square number that goes into 50? Yes, 25. The next line down here. So I write the factor pair 2 times 25. The 25 can come outside and it will become 5. To be mathematically correct, I put plus or minus 5 because minus times minus is plus. So minus 5 times minus 5 is 25. That would do, but to make it better, that 5 can cancel out with a 5 in there. So I've got 5 coming out of what will be 20. If I multiply those together, and 5 coming out of that, 15, 3 times 5. So this is why this is fitting in with the idea of factors and factor pairs, because we're simplifying things doing those. Okay, so they're the basic rules that you need to know. I'm now going to see those in a few questions. The first few I can probably just talk through, but there will be some that I'll take on and do on paper as I've done for you in the past. So root 3 add root 3, hopefully you'd work that out to be 2 root 3. As you can see, my writing's not that tidy, which is why I'm doing it on pencil and paper. 5 plus root 5, 2 root 5. Root 9 plus root 4. Well, you can't add those up because they're not the same, but look out, this is the square number and this is the square number. So this would simplify to 3, and this would simplify to 2. So it's 3 add 2 is 5. This one, got a whole mix. This is a square number, that will go to 7. This is a square number, so that'll go to 4. But this, I can't do anything with, so it'll just stay there. So I'll end up with 7, take away 4, which is 3, add root through. So there's my dodgy attempt at a 3. That's as good as we can get it, and as good as my writing is. Okay, so look out for which can be square rooted and which I have to say is square roots. Okay, moving on to 2. Remember, this is multiplication sign here, so I can put these together. So this will be written as root 6, because 2 times 3 is 6. This one would be root 15, because I've got 5 times 3. This one, although you've got 3 numbers, it's the same again. So I can do 3 times 7 is 21, then 21 times by 11 is 231. Now these I'll need to do a bit of working on, so these I will be doing on paper at the side. Question 3 says write this in the form square root A times square root B. So that just means the square root of a number times the square root of a number. So what numbers multiply to give you 14, 2 and 7? So we write that as square root of 2 times the square root of 7. You wouldn't normally want to do this as a mathematician because that's making it more complex, although sometimes it does help on certain simplifications. If you looked at E, you've got 46. So 46, 2 numbers that multiply to make 46. I guess you could have 2 and 23. So square root of 2 times the square root of 23. 23 is a prime number, so you couldn't make that any simpler. And 2 is as simple as you can be, so that's the correct answer for that one. Number 4 gives you a slightly different format. A times the square root of b. So this time, if we've got root 20, we're looking for a number that can come outside of that. So try and think of a square number that goes into 20. 4 goes into it, and that's a square number. So when 4 comes outside, remember that is square rooted to 2. And what it would have been is 4 times 5. So what's left inside is 5. 4 5s are 20. The 4 comes outside and is square rooted to become 2. We did another one, such as 98, because 98 is quite a tough one. You need to know that 49 is a square number. So inside here we'd have 49 times 2. 49 square number comes outside, becomes 7 root 2. So for these questions, it's really important that you know square numbers and can think of which of those numbers go into these larger ones. Moving on to question 8, which is on the next slide. So here we're going to be expanding a bracket. So root 3 times root 3. Hopefully by now you've worked out that is 3. And root 3 times by 3 is going to be 3 root 3. And that is done. I think you've picked up that there is a 15-minute limit on these videos. So the extension questions, the harder ones at the end, I'm just going to put in a separate document, and they'll be called lesson 46A, just so the first video is less than 15 minutes. So if you want to see how some of the harder questions are done, then look at lesson 46A, be a very short video just taking you through those. Okay, bye-bye.